Okay, let's go back and review what we learned about slope. How do we find slope? What ratio do we set up? Sam? The rise over the run. So when we are going to, today we're going to work with slope to help us find the function or the equation name for a line on a graph. So to be able to do that, we are going to determine what is the slope of that line using the rise over the run. And then that should help us then be able to pick the equation, because what else did we learn last week about that slope? Where is it located in the equation? What is it? Get off last week's notes, last Friday's? Which would be lesson probably 7. Where is the slope located in the equation? Do you ever write any equations? It's a line with a slope, and that line has an equation name. It has a function name. Okay, maybe it's in lesson 6. I don't know. Find it. I'm looking at Kaylee's 7 notes here, and I see it in there. So. Rise over run is slope, but where is it at in our equation, Dan? It's the multiplier on the what? What's getting multiplied by the slope? The x is, yeah, it's what is, the x is being multiplied by, so it's the multiplier on the x is our slope. So we're going to, first of all, we're going to take in number 1 here, they want us to pick from those 3 names what the slope of this line would be, and so, or what the equation of this line would be, excuse me, but we're going to need the slope first. So let's do this. Let's first plot a couple of points on it, because it does not matter which 2 points we use. Any 2 points on that line, the rise over the run between them will always give the same answer. So everybody can pick their own 2 points and count rise over run. So go ahead and do that. Plot 2 points on that line that you can clearly tell. You would be able to say, okay, this is the ordered pair name. I feel confident. So name 2 of the points on that line, please. And then after you do that, I want you to set up, and I want you to actually write it down on your paper. So let's maybe do that right here. Let's say, what is the rise between those 2 points? And what is the run between those 2 points? So set that up, write that down too, and then figure out the rise over the run between your 2 points. It does not matter what 2 points you use. Now I'm going to go crazy and use some probably unlikely ones that you did not use. Between my points, I get a rise of 5 and a run of 5. What did you get between your 2 points? Well, copy mine. You were supposed to do your own. Tell me what your rise and run are. Harley, what's yours? You don't have it yet. Derek, do you have yours yet?
No.
No. Wade?
I have a rise of 3 and a run of 3.
Okay, you have a rise of 3 and a run of 3. Okay, how about you, Tyler? Do you have anything yet?
No.
Okay, you're getting it yet? How about you, Kaylee? Do you have anything yet? Kaylee?
A rise of 3 and a run of 3.
You have a rise of 3 and a run of 3 also. How about you, Danny? You're still figuring it out? Okay, Sierra? You're still figuring it out. Sylvia? A rise of 1 and a run of 1. Okay, how about you, Sam? A rise of 4 and a run of 4. How about you, Kate? A rise of 3 and a run of 3. As them, there were lots of choices here. Oh, it's Caden, a rise of 3 and a run of 3. Okay, so far I've heard that we have 3 over 3, quite a few of those. We have a 4 over 4, we have a 1 over 1. Was there anything else that I missed? Anybody have a different one yet? Danny? 2 over 2, okay. Anybody else? Okay, well tell me something. Does that mean we all have a different slope? Yes? Okay, what's the slope when it's 3 over 3? What does that simplify to? 1. What's the slope when it's 4 over 4? 1. What's the slope when it's 1 over 1? 1. What's the slope when it's 2 over 2? 2? 1. And what's the slope when it's 5 over 5? Oh, so what's the slope? 1. So the slope is actually 1. It doesn't matter which 2 points we used. We get a rise and a run. Rise over a run, that simplifies to 1. Okay, well that means the multiplier then is 1. So which of those 3 functions would be the equation of this line? A, y equals negative x. B, y equals positive x. Or C, y equals 10x. What do you think it is? If our multiplier on x is 1. Sylvia? B. Sylvia, can you convince the class why it should be B?
Because y equals 1x.
Okay, so y equals x is really y equals 1x, she says, right? When there's an invisible multiplier, that invisible multiplier is 1. Okay, so y equals x is really y equals 1x, and slope is 1. That's what we found out, didn't we? Okay, write that down. It says explain. Okay, now I want us to together do number 2. I want us to pick the origin and then I want us to pick another point on that line that has integer coordinates. So does anybody think they know of another point on that line with nice integer coordinates by looking at your graph? It's easier to see in your graph than it probably is up here on the smartboard. Anybody find one yet? Because I think there's a couple on there. Anybody find one? No? So when I say that I wanted to have integer coordinates, what are we looking for? What kind of a spot are we looking for? Every grid line represents an integer value of 1 unit, whether you're on the y-axis or you're on the x-axis. So we should be looking for where the line crosses an intersection of grid lines. Those would be integer coordinates. So where the line crosses, so I'm going to make a picture of that over here. Where the line crosses, so this is my, and these are not my x and y axis, but instead I'm saying that right here I can tell there's a intersection of grid lines and my line is crossing right there at that spot. So there are 2 of them on there on this graph that are good integer coordinates. Come up with one of them for me. I'm not finding it for you, sorry. Danny, you think you got one? 1, 1? I would have to disagree with that one. I think 1, 1, in fact, I'm going to show you where 1, 1 is on here right now. I'm just going to erase this for a second. And I'm going to say that 1, 1 is right there. Is the line going through that one? No, it isn't, is it? Okay, so it can't be 1, 1. 0. 4, 4. Okay, so that means I'm gonna erase this one, and I'm gonna go with Sierra's now, and that point is right here. Ordered pair of 4, 4 is right there. Is the line going through that? No, right? Okay, wait. I'm sorry, what? Never mind. I don't know where that point is on there. Sorry. Sylvia?
Minus 4, 11.
Okay, so you want me to go up 4 and 1 to the left, you said. So right here, this would be ordered pair -1, 4. Is that where you want me to be? Okay. How about Sam?
1.
Or 1 -4, she says. You know what? These ladies found 2 of the 2 points that I said have integer coordinates. So now that means we can use any of those 2 of those 3 points to help us find the slope of this line. So go, find the slope of this line. Do a rise over a run again down here. Say rise over run equals and there's a variety of rise over run that we can possibly get depending on which 2 points you use and which direction you go. If you go from a lower point to an upper point or an upper point to a lower. And then after you get your rise over run, would you simplify it, please? Let's see if we all get the same thing. Okay, all over my graph, and you don't necessarily have to do this on yours, but all over my graph, I'm going to write some of the possible rises over runs that I'm thinking I should see on some papers if I went to your paper. I think, are there any others? There's 4 possible rise over run that I come up with, depending on which points you actually use. Anybody come up with anything else that you'd like to share? Okay, I think I'll just take my first one. In other words, to get a rise of +8, I'll show you what I did. To get a rise of +8, I started down here at the very bottom point right here. I want you paying attention. For me to get a +8 rise, that means I started at this point and I went up until I was straight across from that other point, and I had to go up 8 units. And then I went over to the left 2 units. That's where my -2 came from. So that's using these 2 points, starting at the bottom point and going up to the top point. Okay? Anybody use the same thing as I did? Yeah? Okay. Anybody get the -8 over +2? Anybody get the +4 over -1? Okay, a couple of you. How about the -4 over the +1? We need to get one of those guys, unless you have a new one that you want to share with us. Well, regardless, they all simplify to what class? Negative, just the slope, not the x. I don't want the x right now. Our rise over run should simplify to -4. Okay, that's what our slope should be. So in this one, we're going to say slope is -4. In which equation is -4 the multiplier? Equation A, B, or C? C. So y equals -4x. Oh, mine is skipping there for some reason. Has a multiplier negative 4. Questions? Okay, I want us to, let's see. Okay. Let's do an XY table below each of these. So we're not moving on to the next page yet here. So for this one, when we said that the equation that matches that is y equals x, that says to do what? It says to multiply the input, the x, multiply the input by 1 to get the output. I know that's a lot of writing, but this is, we gotta make sure we understand that our rule is actually showing up in the equation. So multiply the input by 1 to get the output. So we jumped back to number 1. So if we chose some x values, I don't know, let's choose these guys for the fun of it. What would happen if we took negative 2 times 1? What would we get for the y value? Negative 2 times 1. What would we get? Negative 2. What would we get if we took our input negative 1 times 1? Negative 1 would be our output. How about 0 times 1? What's that? 0. What's 1 times 1? 1. And 2 times 1 is 2. Are all those points up on our line? Will you check? Are all those points up on our line? Negative 2, 2. Negative 1, negative 1. Well, we already can see that 1, 1 is. And did we have another? What was the other one? Oh, 6, 6 I used. That's not in my table. But, oh, there's 0, 0. There's 2, 2. Oh, there's negative 1, negative 1. And there's negative 2, negative 2. All those points that are in our table should be on that line that matches our equation that has that rule. Yes, wait. No. You just hang in there till homework time. Okay. Let's make an XY table for the next one. After we state the rule. What's the rule for this one? Multiply the input by? No. What's the equation say? Multiply the input by, what's the multiplier on the x value? Negative 4. Multiply the input by negative 4 to get the output. So we're going to specifically use those x values from those 3 points that we have identified on our line, okay? So we have the negative 1 x value, we have the 0 x value, and a positive 1. So let's just use those guys this time. What's negative 1 times 4? Negative 1 times a positive, no, or negative 4, excuse me. Negative 1 times negative 4. Positive 4. What's 0 times negative 4? 0. And what's 1 times negative 4? Negative 4. Now let's go see if that matches the names we gave our points up on the graph. Does it? Negative 1, positive 4. Yep, that's that fellow right here. 0, 0, that's this guy right here. Positive 1, negative 4. Yep, that's on our line. So again, our equation with that rule gets us the right y values. So again, they all belong together. We have to connect all these ideas. Okay, let's go to the back side. Try and be a little quicker with these two. Okay, let's plot this point right here, and I'm thinking that it looks like there's a good intersection of grid lines for that guy right there. I'm thinking there's another one right here, and another one right here, and another one right here. Okay. Use any 2 points you want and get a rise over a run. I'll name these points and then you can copy them if you want. Okay, there's all kinds of different rises over runs between, depending on which 2 points you pick, depending on which direction you go, if you go up or down. But in the end, we should all get a slope of 3. Did you get a 3 with your rise over run? Okay, I used this one right here. I went up 3 and I went over 1. That's what I used. And it should simplify to 3. So which equation should we circle, class? A, B, or C? C. Okay. And we will say because why? The slope is 3. And for y equals 3x, the multiplier on x is 3. And that's what we want it to be. Okay, this one we won't take time to make an xy table, but let's just say what is the rule for this one? What would the rule be in this one? You got to do the input to get the output. You have to do the input in this one to get the output. Multiply the input by what? 3 to get the output. So would 3 times 2, would that be 6? Yeah. Would 3 times 1 be 3? Would 3 times 0 be 0? Would 3 times a negative 1 be a negative 3? Yeah. Would 3 times a negative 2 be a negative 6? Okay, it works, doesn't it? So we have a good equation, a good slope. Okay, let's do one more here because then we're going to make some conclusions about lines and their slopes, okay? So let's use this point. Let's all use the same points this time. Let's use that point and, just for the fun of it, let's go all the way down here and use this one, okay? So this is ordered pair 0, 0. And I can see this one's going through an intersection of grid lines, so I'm going to use 5, negative 5. And this time, I'm going to be crazy and go down. I want to start at the top point. I'm going to let the top point be the one in charge this time. I'm going to go down 5, so rise is going to be negative 5. And the run, I have to go to the right 5 units plus 5. Well, what does that divide out to? A negative 5 divided by a positive 5. A negative 1. Okay. So our slope is negative 1. Which equation matches this time? A, B, or C? Yeah, because y equals negative x is really what? What was it before it got cleaned up? That negative x means what? What's the multiplier on when there's just a negative sign in front of the x? What's the multiplier? Negative 1. So negative x really means negative 1x. And slope is negative 1. That's what we'll say for this one. Well, if the slope is negative 1, that means we take the input and multiply it by negative 1, and we should get the output. So is 5 times negative 1 negative 5? Yeah. Okay, I want us to make a conclusion here, looking at the two graphs on the front of this page and looking at the two that we just did on the back. If the line is rising, if it's going like this, rising from left to right, if it's falling from left to right, what can we say about our slope in terms of its sign, being positive or negative? So would you look and tell me, if the line rises from left to right, what happened with our slope, both times? Okay, which ones are rising? Which problem numbers? 3 is
rising.
3 is rising from left to right, so this one is rising, and how about on the front side? Which one's rising on the front? Number 1, okay, and in number 1, our slope was positive 1, and in number 3, our slope was positive, did I change pages or not? I didn't, okay. And in number 3, our slope is a positive 3. So what can we say about the slope when the line is rising from left to right? What type of slope does it have? A positive slope, yep. So if the line is rising from left to right, you better come up with a positive slope then. Well then, let's go look at the other two that are falling. Number 4 is a falling line from left to right. As we read across a page from left to right, it is going down. And number 2 on the front side, what's happening? There's a falling line, and we got a negative 4 slope. So when the line is falling from left to right, the slope better be what? Negative. It better be a negative. And last but not least, we're going to make sure that we understand that the coefficient on x, remember coefficient means what again? The multiplier. It isn't always invisible, but it's the multiplier on x. So what's the coefficient on x called? No, what's it called in this? What did we call our multiplier? Slope. Slope. The coefficient on x is the slope in a linear equation. Okay? Okay, those are all 3 things that you need to get memorized. You need to understand that that's important things in our linear functions. Okay, let's go do one more thing. Our other learning goal, which states I can compare 2 functions using graphs. Okay, so tell who reached their goal first by completing the table and graphing the functions. So the goal is to score 60 points. Marcus scores 15 points per level, and Liza scores 20 points per level. We're supposed to complete the tables and then make a graph. So let's just take care of Marcus here first, okay? Marcus scores 15 points per level. So level 1, he scores 15 points. 1 times 15 equals 15, right? Level 2, how many points would it be? How much? 30. So we'll put a 30 in the output. And level 3, 3 times 15, 45. Okay, first of all, our multiplier every time was what? 15. Let's circle that. Our multiplier every time was 15. So what would the equation be for Marcus's scoring? The multiplier is the slope is the coefficient on the x. It's what we're doing to the input to get the output, Danny? Okay, 15x, y equals 15x. That's Marcus. This is Marcus's equation. Let's go graph Marcus's 3 points right away, okay? Go over there and graph, on the graph, Marcus's 3 points, and then you're gonna draw a ray going from the origin up through those 3 points and beyond. And at the end of your ray, I want you to write the equation of that line, even though it's a ray. It's still a ray is part of a line. Okay, that's Marcus. Okay, should we read through Liza, or are you still drowning? Still catching up? Okay, Liza scores 20 points per level. So in the first level, Liza scores 1 times 20, which is 20, like they already have it, right? So in the second level, Liza will score 2 times 20. How many points will Liza score? 40. So we can go put that in our table. And at level 3, 20 points times 3 is 60. Okay, let's write an equation for that one. I'm going to write it above this time. What's the multiplier this time? 20, so what's our equation going to be? Y equals 20x this time. That is Liza's equation. And let's go have a picture of it. What does the line look like? And again, draw a nice ray. See, that didn't go very well. And at the end of Liza's ray, also put the equation for her line, which a ray is part of a line. Okay, who reached the goal first, Marcus or Liza? Liza, I'm hearing. Anybody want to disagree that Marcus reached it before Liza did? How can you tell? Give me some ways you can tell that Liza reached it first. Sylvia? Okay, so in other words, in the table, when they're both at level 3, Liza's reached it, but Marcus is still not there, right? So the table shows it. And how does the graph show it? How does the graph show that Liza got there first? It has to do with the slope and the steepness of the line. Which one has a bigger slope? Liza, her multiplier is bigger than Marcus's, right? The slope is bigger. So if the slope is bigger, what happens to the line? Is it steeper or less steep? Steeper. The bigger the multiplier, the steeper the line, the faster it's going to get there, right? So we go to 60 right here on the y-axis, and we say, you know what? We have right here, if we just draw an imaginary dashed line going through that, it crosses through Liza's line right at that ordered pair of 360, and Marcus's line, he hasn't, didn't keep, when did Marcus get to 60 points?
4.
At 4, so right here, this is ordered pair 460. Oh my, I didn't do that very well. Ordered pair 460 is when Marcus got there, right here. So Liza definitely got there first. So who reached the goal first? We're gonna say Liza did. Okay, questions on comparing and understanding how to make the comparison both with the table and with an equation and with a graph and all the different things, ways of doing the comparison. Okay, then let me check. Yes, you need loose leaf, so you can go ahead and get that out. Does anybody need any part of the notes anymore? Close them up.